see, so 1.04 over 4, so about a quarter, huh? So, yeah, about 0.26. So yeah, it's a little bit more than halfway to a half, right? Yeah, right, a little more than halfway to a half, which is kind of what you expect. Right, because the sine is rising slower and slower as you wind around, right? And so, how about the cosine of pi over 12? Well, let's use this other one. So that'll be the cosine of pi over 4 minus the cosine of pi over 6, which we can write as cosine pi over 4, cosine pi over 6, minus, or plus, sine pi over 4, sine pi over 6. And so that's root 2 over 2, root 3 over 2, plus root 2 over 2, 1/2. And so that's square root of 6 plus square root of 2 over 4. So a lot like this one, only with a plus sign, right? And that's going to give us, when we add here, 3.86 about over 4. So 3.86 over 4. And that's approximately equal to 0.9, 4? Let's see, so 36, 26, yeah, 96. Change a little bit bigger, 0.96, huh? We'll check that on a calculator, but should be about right. Which looks, you know, so square root of 3 over 2 is about 0.866. So we're significantly closer to 1 at 0.96. And that seems about right. So that's just a review of using the addition identities to get some new angles in exact form. You can always approximate how. Well, it used to be, you know, ask your grandparents. They had to look it up in a table and then interpolate and extrapolate and that sort of thing from the table. But now you have little handheld calculators, maybe even your phone, right? You can say, Siri, what's the cosine of pi over 12? I don't know, I have never tried that. But I don't have an iPhone, so maybe that explains it. I don't use the other one either. So.
Alexa, Alexa does do it.
Yeah, what is it?
So,
Hey Google, is that what you're supposed to say or something?
Google.
she'll do like simple signs if you ask her, but if you throw in like decimals or something, she'll be like, sorry, I don't know that, or something.
Yeah. She relays all your questions to the great eye in the sky. Just be aware of that. Okay. So how about half angle formula? So how about pi over 8, right? So if you want pi over, where is pi over 8? Well, that's going to be somewhere in here, right? Between pi over 6 and pi over 12. Halfway to pi over 4, right? So take this interval, cut it in half. Oh yeah, it'll be halfway in there, right? So pi over 8. So can we get those values? Sure. What's the sine of pi over 8? Well, look over here. We got sine of pi over 8 in terms of sine pi over 4, right? Oh, sorry, no, that's wrong. That's the double angle formula. I want the half angle formula. So sine of pi over 8 in terms of cosine pi over 4. And we know cosine pi over 4. So, do we not? Cosine pi over 4 root 2 over 2 on Tuesday. So, yeah, so sine pi over 8. Now, is that positive or negative? this is where user discretion is advised. What quadrant are we in? Quadrant
First
1,
quadrant.
where sine and cosine are
Six.
both positive, right?
Positive.
So we're gonna say positive square root. 1, now with sine, it's gonna be minus, right? All over 2. So this is gonna be the positive square root of 1 minus root 2 over 2, all over 2. So you got a complex fraction and nested radicals. Oh dear. So it goes, right? Can we simplify that? That was a Kurt Vonnegut quote.
Kurt Vonnegut.
So it goes. What are you gonna do? How do you simplify that? See, this is the kind of thing that trips up.
No, you could
You can separate it, right?
you could separate them. Get the square root of 1 minus square root of 2 of 2 over the square root of 2.
Oh, so it's make them separate fractions?
I mean,
1/2
that-
minus.
Yeah.
Does it divide each term in the numerator separately by 2? That would work?
And then you could multiply by 1, which would be radical 2 over radical 2.
Yeah, but you've already got the radical upstairs, so that'll just bring it downstairs, yeah. Right, in general, multiplying by 1, very safe, good thing. In fact, that's what I want to do. I want to multiply by 1 in the form of 2 over 2. I think that's a faster way of getting where I want to get. All right? So what's going to happen on the top?
You get 1 minus square root of 2. I mean,
2 minus root 2. And on the bottom, which is a perfect square, right? So this comes out as the positive square root of 2 minus root 2 nested, right? All over 2.
Mm-hmm.
It's a lot of 2's.
It is Tuesday.
Yeah, it's appropriate. And then cosine pi over 8? We have to fuss about that a lot, or can we just sort of use what we got, right? It's going to be the same, only with a plus sign, right? It's 1 plus cosine. It's still in terms of cosine, right? It's 1 plus cosine pi over 4. And so that gives us same thing, right? Or here, but with a plus sign. Notice that the whole thing is under the radical here, and here only the numerator is under the radical, so I've rationalized the denominator as sort of, while clearing out the complex fraction, you also get a perfect square in the denominator, so that's nice. How about, we keep going this way, right? So sine of pi over 16? Well, that's going to be positive again, right? Because we're still in the first quadrant. Square root of 1 minus cosine pi over 8 over 2, right? Half angle formula. So that then leads to, well, substitute for, we've already computed cosine pi over 8, right? That's going to be a plus sign, right? So it's going to be 1 minus root 2 plus root 2 over 2 all over 2. Very nice. And does that simplify? Yeah, again, I'm going to multiply by 2 over 2. Clearing out the fractions on the top. There's only one, but clearing it out. So I end up with, and on the bottom I end up with the square root of 4 again, right, which is 2. So the radical will only apply to the top now. It'll be 2 minus square root of 2 plus square root of 2 all over 2. Another 2. And you can kind of imagine this continuing, right? Sine of pi over 32, pi over 64. You can get all of those, right? And then, you know, any sum of that with one of these other things that we know, we can also get. So you can start filling in a lot of exact values in here. But, you know, most of the values we can't get exactly like this, but in terms of radicals, right? But, I mean, they're all irrational here, right? All these radical things. But they're algebraic irrationals. I mean, they're solutions to polynomial equations with integer coefficients. Remember all that? Yeah, all right, that's what that means. So how about cosine of pi over 16? Is that easy now, or do we have to do all this work still? Well, it's going to be the same as this, except with a plus sign, right? How you just go here and change this minus sign to a plus sign, and say, yeah, I got that. That's 2 plus cosine of square root of 2 plus square root of 2 all over 2. All right, again. So it makes a big difference whether it's a plus or a minus. These values are small, right? Sine of